So in Rust, a collection is an abstract data type that groups multiple items into a single unit, allowing for efficient data management and manipulation. The purpose of collections are to enable developers to store, retrieve, and manipulate groups of related objects, facilitating efficient data handling. Rust has many different types of collections. We're going to start off with linear collections, which maintain a sequential ordering of elements, such as arrays, which are fixed size sequences of elements of the same type. Lists, which are ordered collections that can grow or shrink dynamically. We've got stacks, which follow the LIFO principle, last in, first out. And queues, which follow the FIFO principle, which is follow first in, first out. There are also associative collections, which store elements based on key value pairs. You have sets, which are unordered collections of unique elements, and maps, which are associative arrays that map keys to value. Collections, not just in Rust, but in programming, are extremely important because they provide efficient data storage and retrieval mechanisms, enhance code readability and maintainability, and also offer flexibility in data manipulation and organization. Vectors. Vectors are dynamic arrays that can grow or shrink in size. They store elements contiguously in memory, allowing for efficient indexing, ideal for scenarios requiring dynamic sequential data storage. Hash maps store key value pairs with unique keys. They provide efficient data retrieval based on those keys, and they're suitable for scenarios requiring fast lookups and insertions. Hash sets are unordered collections of unique elements and offer efficient methods for checking membership and eliminating duplicates. They're useful when the uniqueness of element is a priority. Linked lists consist of nodes where each node contains data and a reference to the next node. They allow for efficient insertions and deletions at both ends, and they're suitable for scenarios requiring frequent additions or removals of elements from the beginning to the end. VecDec is a double-ended queue that allows for efficient additions and removals at both ends, implemented using a growable ring buffer and ideal for queue-like functionality with dynamic sizing. Within this example, we're going to demonstrate how to create a simulation for a security auditing tool you can create in Rust that checks different baseline settings within your Windows 11 operating system. Once we're done with this demonstration, we're then going to move on to implementing a working example. Within this example, or within this working example actually, we're going to be using the Win, Reg, and Windows crates from Rust in order to check things like Secure Boot, BitLocker, Windows Defender, and your TPM 1 or 2 module within your Windows 11 system. We're going to check to see whether or not they're enabled or disabled, and then provide you with feedback on whether or not they're set.